Hi, now we are in a 2010 breeding trial for Eucalyptus bozestoana. It's called Graven's Road, and we use those trials to find out which are the trees that have good genetics for our purposes. And for our purposes, the trees should be straight, the trees should be fast growing, but the fast growing tree is not necessarily the one we want, because in our case only the hardwood is naturally durable and the sapwood is actually not naturally durable, and there's quite a bit of variation in the hardwood in a tree. So I have discs of two trees, and they are more or less the same diameter, and we can visualize what the hardwood is by putting some pH indicator on it. And then we have one tree which has much less hardwood than the other tree, and this tree would be much more valuable to us than that tree which has less hardwood, even if they look the same. Or it can be more extreme. We can have actually smaller trees which have in some cases more hardwood than larger trees. So just like a forester going into a trial and measuring the diameter of the tree doesn't really help us much. So how actually are we doing the assessments for our trees? We need to take wood samples. We need to take wood samples when the trees have developed hardwood, and we have done that in this trial already a couple of years ago. We have developed this handheld tree corer, which is basically a hollow drill, and we can very quickly, in less than a minute, get out a corer in a very easy fashion. And then once we have the cores, we have a wood sample which we then can measure for the amount of hardwood in them. So we have the core sample, and we know which tree it comes from. We put the indicator on it, we know how big the tree is, and we can also measure how much hardwood it has. If we do that over very many trees, of which we also know the genetics, meaning from which tree they come, which heritage they have, then we can calculate the heritability, the genetic control of the trait, and it's quite heritable. So there's quite a bit of genetic control in the amount of hardwood in our trees, and we have now assessed six trials of Eucalyptus bozestoana, and we have done already some selections of this species, and trees which are now available commercially for planting, they are basically selected for good hardwood content. We have done the same thing for Eucalyptus globoidea as well. Okay, apart from how much hardwood is in our trees, then we also need to know how good is the hardwood. There's as much variability in the quality of the hardwood, the durability, as there's in the amount or any other traits in the trees. So there's a shortcut, if you like, and what makes the wood durable is mainly extractives which are deposited into the wood, which gives it the color in the hardwood, and also which gives it the durability. These compounds, they can be extracted, and some of them have fungicidal or insecticidal properties, and they provide the decay resistance. So we can extract these compounds. It's a bit like making coffee or tea. We grind the wood up, put some hot solvents over it, evaporate then the solvent, and we can measure the mass which is left over, or just look at the color of the extract. And here I have two examples. So that's the extracts of two timbers, and you can see one is much darker and the other is much lighter, so there will be much more extractives in this sample than in the other, and we can bet that the high extractive content will result in timber which is much more durable. We have shown that there's a lot of variation in the amount of extracts in our trees, between 2% and more than 20% around here. And we have also shown, together with some colleagues from Australia, Laurie Cookson, we have shown that samples with a high extractive content have also performed very well in one of these fungal decay tests, where they exposed wood samples to wood decaying fungi and measured how much mass is lost. Extracting our wood to measure extractives in that way is also very labor intensive. So we came up with a quick way of measuring it, and we can use infrared spectroscopy, which is basically looking at the color of light, but in frequencies which we can't recognize with our eye. and but machine can, and then these correlate to the chemistry of the wood, and we can do this spectroscopy assessments within seconds, non-destructively on wood. And we take our cores from the trials, bring them to the lab, and then scan them with the infrared spectrometer, and we have calibrated it against our extractive content measurements, and we get quite accurate prediction of extractive content. With that, we have thousands of trees measured, characterized for extractive content, and we could again calculate the genetic control over it, and the amount of extractives in our trees is highly heritable. Like you see behind me, all these variation in the trees in shape and in size, that's under genetic control, and as is the extractive contents and the durability in the trees. And therefore it's very important for us that we have a strong breeding program to make sure that we select the right genetics to be planted in the production forests, and that's happening from this year onwards. We have improved plants available, so when they are then ready to be harvested, we are sure that the products which are manufactured, like the posts for the vineyards, will also perform, and the customers are satisfied with our products. That's important in particular for young trees, because we know for young trees the wood properties are not ideal, and we know that for radiata pine the wood is not stiff and dimensionally stable as a young age, but it's also true to some degree for natural durability. If you look up the natural durable standards, they state that the inside of the tree, the hardwood, the inner hardwood, is less durable than the outer hardwood. So if we want to produce posts from our younger trees, we particularly need to make sure that we have the best genetics in our trials. And already papers or researchers over in Australia have shown that these trees do exist. There are trees which at young age already produce highly durable wood. While we can make sure that the trees which go into our plantations are best genetics which we can find, we can also think about, is it possible to grade the timber for durability? And because we have now shown with the infrared spectroscopy we can do non-destructive quick measurements of durability, I think there's a real opportunity that we start to develop a grading standard or a quality control system for our durable timber as well.
In planting a breeding population or a progeny trial, collections have been made in Australia of from individual trees that we've identified now and pedigreed as the trial was planted into the various families. So the mother trees in Australia have produced sufficient seedlings for us to establish these trials at scale. And the Cravens Road trial has, this section of it has 60 different mothers that have had the seedlings grown and evaluated for us to identify then these elite trees. So this elite tree, having found it in our trial, it's a very important step of being able to take signwood, which is the upper stem, a selection of branch, normally in January and February period, and that is collected by Proseed. Paul Schroeder comes up from Amberley and he takes those young sign shoots and grafts them onto rootstock that he's had grown in the nursery, and then that rootstock, those grafted trees have been used to establish Proseed's seed orchard. And the seed orchard, when you bring together the elite trees from all of those different families, and we only choose the best families, so not every family goes to the seed orchard, but once they're in the seed orchard, that's where the real major genetic improvement occurs, because those various families can flower and we can get outcrossing between those individual trees that then produces new seed that we hope has some of the best and even better genetics than any of the original parent trees. What's been interesting about this Cravens Road site is it's actually within the stop banks of the Wairau River system. So behind me there's a big stop bank, and in July this year the water was lapping at the top of it. We had a major flood event that had water flowing up to 3 metres up the stem across this entire trial. There's trees further up in the stand that have been pushed right over, but it is outstanding to see this trial after that event has survived it as well as it has. I was distressed to know the flood was happening when it was, but now that we've seen only 3 months later, you'd hardly believe that it had occurred. That's interesting because we see Eucalyptus persistuana as having a place in New Zealand's riverbed systems. On these fertile, silty, even quite gravelly soils, it seems well adapted to being able to thrive and even to handle these flood conditions. So we this year established with the Hawke's Bay Regional Council a similar trial in the Tukituki riverbed up near Waipukurau in Hawke's Bay, and I'm pretty excited to see what happens when they get a flood in that trial as well.